Hi everyone, welcome to today's session. Today we are going to see computer networks. Under computer networks, we are going to see the following topics, that is topology, and then communication devices of computer, and then client server concept, next network protocols. So these are the topics we are going to cover today. So first we will move on to first topic, that is topology. So what does topology means? Topology is the pattern of interconnection of nodes in a local area network. That is in a LAN, in a local area network, how the computers and all arranged. That is arrangement of computers in a computer network only is known as topology. Okay. So here we will have some of the topologies, that is bus topology first, then tree topology, then star topology, and then ring topology. Like that, four topologies today we are going to see. So first we will move on to bus topology. So bus topology, it is also known as linear topology. That means one after other devices are going to be connected in a single common cable. So that's why it is called a linear. So there will be a sequence will be there in the arrangement of the computers. Each node attaches directly to a common cable which acts as a backbone. So what is the name given for the common cable is backbone. So backbone wire will be there. In that wire, in that cable, every node, that is the computer which is connected to the network only makes a node. It will get the name node. Okay. So each computer, each node, it attaches directly to a common cable, that is only acting as that common cable only acting as a backbone here. The device which is want to communicate with another device on the network sends a broadcast message. What is meant by broadcast message? Broadcast means from one to many devices. One to many, if information is passed, means that is called a broadcast. Unicast means one to one, and multicast means one to particular group of computers alone. Okay, so here one to many. So whichever devices are connected with the common cable, every device will receive that message. Okay, so in both the directions onto the wire, that all the other devices also will see that message. Okay, then intended recipient, that is to whom that message is need to be transmitted. No, that intended recipient, the receiver, actually accepts and processes the message. So that intended recipient only, it will accept the message and it will process the message. That means it will work on that message. Data is transmitted in small blocks. How the data is transmitted from the device? It is transmitted as a small block and it is called as packet. Okay, so what is the name given for that small block of data? Packet. Okay, so each packet has a header containing the destination address. For example, if you are sending any gift to any person through post, so you need to write the address on that postal cover. Yes or no? So in that postal cover, you will write all the details correctly. All the destination person's address, no, that is the receiver's address, you will write correctly. In the same manner, any data, if it is transmitted in the network, so that packet will have the header information that contains the destination address, then the sequence number for every packet will be assigned in that packet. Okay, so when the data is transmitted on the cable, the destination node identifies the address on the packet and thereby process the data. So which node to which node that data is actually sent, no, that node will identify the address of the data and then address on that packet, and then it will process the data. If it is for that, then it will process the data, it will accept and process the data. So like that, bus topology arrangement will be there. A single common cable is there. In that common cable, all the other nodes, no, that is computers, are connected to that common cable. Even printer also is connected here, server machine also is connected here in the common cable. At both the ends we have the terminator, that is the stop point we have in the cable. Okay, so what are the advantages we have in the bus topology? So only single common cable, common data path only is needed for connecting all the nodes. So the bus topology uses very short cable length, which considerably reduces the installation cost. So we no need to spend much amount for buying hubs or switcher or any cable length. Also lesser cable length we can buy and we can install here. This is one of the advantage. And then it is linear architecture, so that it is very simple and reliable. So it's simple to construct, and then additional nodes can be easily connected to the existing bus network at any point along the length of the transmission medium. That is, along that cable length we can insert any node additionally, that easily we can connect to the existing bus cable. Okay, bus network. So Ethernet bus topologies are relatively easy to install. It is very easy to construct or install. So 10 base 2, that is thin net, and 10 base 5 is called as thick net. Both were very popular in among bus topology. So what are the drawbacks of bus topology? So bus networks works best with a limited number of devices only. So only a limited number of devices we can connect in the common cable. And then if the backbone cable fails, because that is a common cable, common single cable, if it is fails, the entire network effectively becomes unusable. So we cannot able to transmit any data from one device to another device. Fault detection, that is detecting of fault and isolation of fault, is very difficult in the case of the that is mistake where the error has occurred, that is detection and isolation of that fault. No, it's very difficult in the bus topology. This is because there is no central control over the bus topology, because central control is not given to any node. So any particular node is not having the centralized control. So it's very difficult to find out the fault, where the fault has occurred, and to isolate the fault also. If the central bus length becomes too long, then repeaters we have to use to amplify the signals. So what is the use of this repeater device? Repeater is actually one device, networking device, which is used to amplify, that is it will strengthen the signal. Okay, after certain limit, after certain distance, the signal strength will become very weak. So in order to increase the strength of the signal, because at the destination the signal need to be transmitted in the same manner how the sender sent that signal. Okay, so the strength of the signal should be very strong when it is to be transmitted over a long distance, so that if the cable length is the common cable length is very lengthy, means after certain distance we need to install one device called repeater device in order to amplify, that is to strengthen the signal. Okay, and then since each node is directly connected to the central bus, there has to be some way of deciding who can use the network at any given time. So at a time, every node is trying to transmit the data, broadcast the data. So automatically the traffic will occur. So congestion, network congestion, that in the cable, no data traffic will occur. So this is another diagram for relating to bus topology. So network devices are there, and then drop line is there. Okay, and then this is the backbone cable, and at the two ends we have the terminator. This is the example for bus topology. Next is star topology. So you just imagine the picture of star. So there will be central common node. Around that common node we'll have a central hub device will be there, central one connecting device. Around that device we have the number of other nodes. Okay, so like that star, imagine star how it will be looking like. So same manner here star topology we are going to construct with the computers. Okay, so star network has a central connection. That means in a LAN, how what kind of topologies, arrangement, computer arrangement, how we can arrange. Okay, in a classroom we will arrange disks, no? In the same manner in a computer, in a network, what are the arrangements we can follow, that is order we can follow in order to form the networks, different topology networks. So for that only we are seeing next topology, that is star topology. In a star way we can arrange the computer nodes. Okay, so star network has a central connection point called a hub node. So it will be having the central connection point, that is called a hub node. Already we have studied some of the terms which are related to the computer networks. Hub, switch and all we studied. This is the connecting device. So hub node will be there as a central point to which all the other nodes are connected by a single path. So using single common cable, every node will be connecting to the hub node. So every individual node will be having the wire cable in order to connect to hub. Then from that hub another device also can be connected with the help of the cable. So every individual node will have to use a separate cable in order to connect to this hub node. Okay, so each node has a dedicated set of wires, cable connecting to central network hub. All traffic will be passing through the hub only, that is all data transmission will be passing through hub only. So the hub is used for isolating the network problems and gathering the network statistics, because in bus topology we have studied that fault detection is not at all easy to find out. Okay, because there is no central control, but here the central control will be given to hub node. Okay, hub device. So that device will be used for isolating the network problems, where the problem has occurred, in which device the problem has occurred, and also it will collect the information about the that is network information it will collect. So it is used in most existing information networks involving data communication networks and voice communication networks, where we are transmitting the data no, and where we are transmitting voice no, in those communication networks and all, this star topology is going to be used. So this is the example diagram for star topology. There is a central hub device, that with that hub device all the other nodes are connected here, all the other computers and are connected to this hub. Okay, this is also another example for hub. Okay, star topology. Next, advantages: it is easy to install and wire, and no disruptions to the network takes place while connecting or removing the devices. Failure of single connection does not affect the entire network, because only that single device will get affected. We can remove that device by separating the cable. Okay, because every node will have the individual wire. If we disconnect that wire, then that node will be removed from the network. Okay, so failure node can be easily removed. It just involves disconnecting one node from a functional network. This also helps in easy reconfiguration of the network. So easily we can reconfigure, we can rearrange the network, and fault detection will be very easier in a star topology. What are the disadvantages? Because every node is directly connected to the center, large amount of cable is needed, because every individual node will have to use the common in its own cable. Okay, so increases the installation cost of the network, because number of hubs if it is increases and number of wires increases, automatically the cost installation cost also will get increased. And then entire network it's dependent on the central hub, that is central node. It may be hub or switch or concentrator. If any one of this connecting node is the central node is fail, okay, entire networks will go down. We cannot able to do any data transmission. Like bus topology, common cable, backbone cable, if it fails, we cannot able to transmit data. In the same manner, in star topology also, central node if it is getting failed, the entire networks will go down. Okay, next topology is tree topology. You can imagine the tree picture. You need to invert the tree picture. So if you invert the tree picture, if you reverse the tree, how will you see the tree image? So root will be at the top and bottom will be having all the branches and leaves and its leaves. In the same manner, here computers are going to be arranged. That is the root node, central hub node will be there. It is a combination of actually star and bus topology. So it will use both the topologies techniques in order to make the tree topology. So the networks looks like an inverted tree with the central root branching and then sub branching down to the nodes. So there will be branching and sub branches will be there up to the nodes. Nodes is like a leaves. Okay, so like that the root is going to be at the top, and then from that branching will be there and sub branching will be there down to the nodes. So it integrates multiple star topologies together onto a bus. That is, a single common cable is going to be used. That is like a bus topology. With that bus single common cable, all the other different star LANs are going to be connected. So that every star topology will be having the central hub node. So that central hub node is going to be connected to the central bus here. We will see the example of picture, then you will understand. Only hub devices connect directly to the tree bus. See here, only hub devices are connecting to the bus. Okay, so there is a bus kind of arrangement is also there, and then star arrangement is also there. So every star LAN, this is making on LAN, and this is another LAN, this is another LAN, this is another LAN. So it is following star topology. Okay, so star arrangement, this LAN is following star arrangement. So every group of networks that is every LAN having a central hub. This central hub is connected to common cable. So here no systems, no devices are directly connected to the common cable. So that is the difference between the bus topology and the tree topology. In bus topology, every node directly connects to the common cable, but here the nodes first connected to central hub, that central hubs only, all the central hubs of different LANs only, different star LANs only connecting to this common bus. So that's why it is called a tree topology. Okay, so what are the advantages of this tree topology? This is a hybrid approach, supports future expandability of the networks. So in the same way, we can extend this common cable and we can attach the nodes like this. So we can increase the number of nodes here in the tree topology. So expandability is very easier in this case of tree topology than the bus and star topology. Tree topology is best suited for applications which have a hierarchical flow of data and the control. So hierarchically, any data or control need to be provided from top to bottom, means we can go for this kind of tree topology. So central control need to be there. From that central control, another sub control. Then from that sub control, another control if you want to provide. So like that, data also can be transmitted from root to subroot, and then subroot to another branches. Like that we can follow the data also, we can transmit the data also, and we can transmit the control also. Okay, so these are the advantages of tree topology. And what are the disadvantages we have? So overall length of each segment, that is each part, no, each division, no, is limited by the type of cabling used. So we are here also we are depending on the cables only. So there should be limit in the cables usage. And then if the backbone line breaks, that is common cable line, no, common bus line, if it is breaks, entire segment will be going down. It is more difficult to configure and wire than the other topologies. It's very difficult to find out the mistake also and configure the like other topologies. It's very difficult to insert the nodes, no, like other topologies. These are the disadvantages of the tree topology. This is also another picture which is indicating the tree topology. So here you can see we can call the node which is connected to network, no, we can call either as a node or a workstation. Here they have given like workstation. Actually the computer only is called in the name of workstation and the node when it is connected to or when it is a part of a network. So this is making one LAN, and this is making another LAN, this is making another LAN. So this is following star topology. This LAN is following star topology, this LAN also following star topology, and the third one also following star topology. So all these star LANs are connecting to the central common bus. So entirely it is making a tree topology. Entirely this entire LAN is making a tree topology, following tree topology. Next topology is ring topology. It's otherwise called as circular. So you know what is the image of ring. Okay, you just imagine how the ring will be looking like. So it will be like a circular shape. Okay, so each node is connected to two and only two neighboring nodes. So just imagine if you have a chain, okay, chain with beads. So in that beads, one bead will be having the that is a forwarded side and backward side. It will be having two beads only. So likewise each node, you just imagine this node like a bead. Okay, so that bead node will be having two neighboring nodes only. So two neighboring beads only will be there. So similar like, so from one node to another node, any data needs to be transmitted means the data will be forwarded to the next node only, either in a reverse direction or in a forward direction it will be transmitted. Okay, so data is accepted from one of the neighboring nodes only, and it is transmitted onwards to the another node, either in a clockwise or anti-clockwise we can send the data. So data token travels in one direction only, either in a clockwise direction or anti-clockwise direction. It will be rotating or it will be transmitting the data at a time. So from node to node around the ring. After passing through each node, it returns to the sending node. So if it passes through every node, which node is having the token, that will be receiving the data and will be processing the data. And finally that node which receives that packet, no, will be remove that packet. Okay, so like that the data transmission will be taken place in the ring topology. So here you can see the ring token is passed to token will be given to any node. So the node which wants to transmit the data will be having that token. So with the help of the token only the data can be transmitted to the other nodes. Next is advantages of ring topology. It is cheaper to install and expand also. Transmitting network is not affected by high traffic or by adding more nodes, as only the nodes having tokens can transmit the data, because all the other nodes cannot be able to send the data, because if it is having the token only, okay, that can able to transmit the data. Then the disadvantages of ring topology: troubleshooting is difficult in ring topology. So it's very difficult to find out the fault. Okay, so troubleshooting is very difficult in ring topology, and adding or deleting the computers, no, it will disturb the network activity, because it is like a ring shape. So if you add or if you delete one node, automatically there will be a disconnection will be occur, or some disturbances will occur in order to transmit the data. So failure of one computer will disturb the entire network. So even one computer, if it fails, entire network will go down. Okay, these are the disadvantages of ring topology. Next we will see some of the communication devices of the computer. So cables, with the help of cable we can able to communicate. So networked computers are connected to a system of cables, some of the cables will be running short distances, and some of the cables will cover between the cities and the countries. Some may go up to cities and countries also. Some of the cables will be running only a short distance, will be covering only short distances. So there are three main types of cable which are found in the LAN, that is local area network. So in local area network we can use these types of cables, that is twisted pair cable and coaxial cable. Third one is fiber optic cable. So how the twisted pair cable will be looking like? It is looking like a telephone wire, and coaxial cable will be looking like a cable television wire, and a fiber optic cable, it will transmit light instead of electricity. So instead of electricity, it is going to transmit the light only and has a greater speed and capacity compared to the other two cables. It is only having a greatest speed and the capacity also, that is more amount of data can be transmitted at a time. See here, you can see the picture of twisted pair cable. See here, every wire, it is twisted. Two pairs of wires are twisted here. Totally four are there. So in every pair, we have two wires that is twisted together. So this will transmit 2 bit. This will transmit 2 bit of information. This also will be transmitting 2 bit, and the other one also will be transmitting 2 bits. So totally 8 bits of information is going to be transmitted with the help of this twisted pair. Then coaxial cable, it is similar like a cable TV, cable television network wire only. Okay, and then fiber optic cable. So this can able to transmit a huge amount of data. It will transmit the data in the form of light. Okay, and next one is this is also another communication device which is used in the computer, inside the computer, that is buses and ports. With the help of ports we can connect the wires, okay, connect the peripheral devices, other devices, external devices and all we can attach to the computer, that is with the CPU we can connect. And buses means internal bus. Here it is indicating internal bus. Internal wires are there in the motherboard. So the wires that connect the computer's internal components are called buses. So the internal components like what? CPU, RAM, that is random access memory, that is main memory chips, are used for exchanging information on a bus. A narrow bus can transmit, that is a small bus will be transmitting 8 bits of information at a time, and then there is a 32-bit, 16-bit buses are also available that are wider and can transmit the data faster, because 16-bit, 32-bit at a time if you are sending means the data amount will be huge. When we are transmitting, we can transmit much amount of data in a faster way. And the slots are there. It can provide a mechanism for adding components. So some of the slot will be there. We can add a component like RAM chip and all. We can add it to that slot, to the internal bus, so that you can extend the computer. So-called daughter cards plug into the slots on the motherboard, adding to the components that one would consider internal to the system unit. So in the motherboard, all these kinds of slots are there. This is the example for motherboard. In this motherboard we have different slots. In that slots these daughter cards and are going to be installed, that is RAM card, then CPU, then ISA card, and then CMOS battery. For everything there is a slot. Everything, all the small devices are going to be fixed here in this slot. So this entire thing will be making a motherboard. Okay, so here internal wires and all is inbuiltly given in this motherboard. Okay, for an external hardware device such as keyboard or printer, so we are going to attach mouse, keyboard and printer devices and all like external hardware devices to the computer. In order to communicate with the computer, it must be able to clip up, that is hook up to the computer. So for that we should have a port. So there should be a plug point or port. Through that way we can insert the wire, okay, insert the cable. This is usually done through a plug called a port, which is located at the back of the computer. That is computer's CPU's backside will have the ports, and then with the help of the ports we can make the other hardware devices, external hardware devices, to be communicate with the computer. There are different types of ports allowing various types of external devices or peripherals to connect to the computer. What is meant by peripherals? Till now I have explained keyboard, mouse, printer, scanner and all these devices which are externally connected from other side, outer side externally, which is going to be connected to the computer only, is known as peripherals. Okay, so this is the port example, ports which are available at the CPU backside. So with the help of this ports we can make the computer to be communicate with the other devices. Next device is modem. This is also one of the communication device. It is used to transmit, translate the analog signal to digital signal and digital to analog signals. For that purpose, we are using this modem. device. It allows one computer to communicate to the another computer which is not linked to it by dedicated cables and ports. So the computers and all is not going to be connected to this modem directly, or with another computer is not connecting directly. So that computers can able to transmit the information or communicate with the other computers with the help of this modem device. Modems allow the computers to use ordinary telephone lines. Modems will use ordinary telephone lines only. The modem will translate the digital information, that is such as information which is found on a CD. So in a CD, how the information will be found? Like a digital format. So that information is going to be transmitted like a sound, that is analog information, analog signal, that is voice signal, and it sends over the telephone network. And from the telephone network, again that data voice signal or analog signal is taken back by the modem which is there at the receiver side. Okay, receiver side also the modem device will be there, sender side also modem device will be there. With the help of this modem only, the receiver side, the analog signal is going to be transmitted into digital form, and that digital information will be viewed in the receiver's computer. Okay, and then network cards. For sharing of data and hardware, computers in a network uses the NICs rather than the standard ports. Okay, so if you want to share any data or a hardware parts or computers in a network, no, we need to have a NICs. Every system will should have a NICs rather than the standard ports. If NIC is there only, we can make that computer to be a part of a network. So next is client server concept. So client and server both are sometimes called as machines. Sometimes we will say it as a in a communication topic wise. If we are dealing with this client server concept, then client and server is known as applications or programs or softwares. So sometimes hardware related any topics if we are discussing, client is also a machine and server is also a machine. And server consists of one or more computers that receive and process the request from one or more client machines. So it is mainly server. From the name itself we can understand that server will do the serving part of the role. Okay, so that is services it will provide. So what kind of services? Whatever request it is receiving from the client, it will process that request and it will send back the information to the client machine. It is a program running on a computer that delivers a specific service such as email. So the server will have a will provide a specific service like a email service. Sometimes the term server is used to refer to the host computer also. A client is an individual user's computer or a user application. We will call user computer also, or user application, that is software also we will see. That does a certain amount of processing on its own. So certain amount of processing it will do on its own. The client machine also will do on its own. It also sends the request and sends and requests to and from one or more servers for other processing and our data. Client is a program that communicates with the server and requests specific resources. Actually, a client always will do the work of requesting work only. Okay, so it will request the services from the server, request the specific resources from the server. So client may communicate with any server in the world that provides the specified services. Particularly in terms of communication, the server and client may refer to the software rather than the computer. So when you are dealing with the term, when you are talking about the communication term, in that case server and client means software. It is not a machine rather than computer. It is called as software only. The internet works on the client server concepts. All internet services are provided by a server and accessed by a client. So the services are all going to be accessed by client and the services are all provided by server only. So this is the example for client server model. All client machines are connected to the server machine. From there only the information is retrieved for the client. Next, last topic is network protocols. So here we are going to see only two types of protocols, that is TCP and IP. Because the data transmission, how it is taken place with the help of this TCP IP only, transmission control protocol. So data transmission is taken care by this TCP protocol, and this internet protocol, it is used to provide the address part for the data, from which device the data is transmitted to which device it need to be sent. All the addresses part, it will be controlled by this internet protocol. So what is meant by protocol? It refers to the official standards and policies which includes the rules, procedures and formats that define communication between the two or more devices over a network. So in a network or in a computer networks, if any computers, any two devices want to communicate with each other, there should be a set of rules need to be followed by both the computers which are connected in the network. So whatever devices are communicating in a network, it should follow certain rules. That rules only is called a set of rules only is known as protocols. So TCP, Transmission Control Protocol, that is the full form of TCP. It uses a set of rules to exchange messages with the other internet points at the information packet level. That means information packet, that is data packet, is going to be checked by this transmission control protocol. And IP protocol, it checks the address level of the packet. Okay, so address of the packet is going to be verified by the internet protocol. So thank you. With this we will end up the today's session. So this your computer networks chapter is getting over.